Good morning. Again, good morning. So, welcome to MikroTik user meeting. So, let's let the fun begin. This is our mom number 68. Usually we have like two really big moms, one in European mom and other one in USA. But right now looks like in Europe we will need to have two moms, at least one in Serbia. Because guys, you are really, the numbers are surprising. We even run out of t-shirts, so sorry. Yeah, we didn't expect such a crowd, so thank you for coming. So, basically, what this presentation is about introducing you to MikroTik, if somebody doesn't know where we are from. So, first of all, we are located here in Europe, in Latvia. We are quite small company. We have only 100 employees. We've been established in 1996. Decided that we need to create software. So, RouterOS was born in 1997. And after a few years, in 2002, we decided that we need to make our own hardware. Maybe somebody knows what was our first router board? Router board 230. Who remembers that one? Please raise a hand. Okay, there's a few guys who have been in with MikroTik as long as I did. So, and the first MikroTik user meeting was in 2006 in Prague. So far, you still have to little bit grow in numbers to beat Indonesia, but you are not far behind. In Indonesia, there was actually 1,400 people present. So we're actually thinking about renting a stadium in Indonesia for the next month. So just to make sure that you know where we are, so we are here in Europe, a little bit north. So we are not in China, we are not in US, we are here in Northern Europe. So basically what we do. So our main goal is to provide routing and wireless equipment for all possible users. So we have router boards, we have cloud core routers, we have cloud router switches. And then we make a software for all those devices that supports all the available features. So in RouterOS, basically it's the operating system of our router board, cloud core router and cloud router switch hardware. And main things are routing, firewall, bandwidth management, wireless, point-to-point, backhaul, hotspot, VPN, and many, many more. So at this moment, RouterOS is based on Linux kernel, version 3.3.5, but we always upgrade to the newest kernel when we release a major release of RouterOS. So right now, RouterOS is version 6, but soon there will be RouterOS version 7. So it will have the latest Linux kernel there. So some of you will say that there is maybe different manufacturers, so why choose MikroTik? So first of all, we already have millions of devices around the world, so it's very probable when you join the company or you talk with some company, you will see the MikroTik device already in that network. So we've been at RouterOS for 18 years, so software is full of features and pretty ready for almost every networking use. And also we have 20,000 specialists, trainers and certified engineers around the world. So if you need help, you will always be able to find some. Just to be sure, there is a small map where we have certified engineers or trainers located in the world. So as you can see, we are almost everywhere. So Last year we had more than 1,600 training classes in RouterOS. There's lots of certified consultants. And we can offer everything, starting from simple CPE for clients' home, ending up with the complex enterprise network equipment. And of course, software is quite capable of many things, so we have thousands of pages of documentation, examples, application guides, even some books. So, who are here from MikroTik? So, only 3 persons, but I think if numbers will be the same, that we will need more people here, because we barely handling. So, my name is Janis, Megis. I'm here for representing training and support, so basically all the technical questions can come to me afterwards if you can find me here. In the registration, there's other 2 guys. One is Norman Zrustanovic. He's our main forum and personal relation guy, so if you see, maybe if you are in our forums, he's Normis there. So you can ask all related to the customer services questions. And then we have a tallest guy here is Edmunds Aperants. He's from sales. So if you want to arrange some big acquisition or something like that, yes, all the prices, all the sales related questions, you need to find that guy. So lunch. So those who paid for meeting and have a voucher we gave you a ticket. With that ticket, lunch will be held upstairs. There's a lunch. You need to show the ticket on the entry and to get in. And please don't disappear. Stay until the end of MOM, because at the end of the MOM there will be lottery. All the guys in that room, including us, will give some free stuff only for persons who are actually in the room at that point. So if you are not here, we will just roll the next person. So if you want to win something, you need to stay until the end. So, and of course, after the raffle, there will be free drinks available, so you can communicate and find some common interests with other guys here and talk some MikroTik. So after this is done, presentations will be moved to the wiki@mikrotik.com. Video that we are making will be available on TikTok, and you will have all licenses, one free license, emailed to you after the MOM. So just because you are here, you will get the license to your email. So special thanks for Netix. There's local guys that really helped us to make this MOM here, so without them we wouldn't be here. So say big thanks to them. And let's go to the interesting stuff. So recently introduced. So of course, AC. So 8.2.11 AC products. So let's start with the most popular one, A6T. So basically, it's exactly the same as product that you already have at N standard. The same size, same looks. So we have 2 models, regular and the sector antenna. And CPU powerful enough to support 866 megabit data rate on AC standard. So it's around 500 megabits of actual data in ideal conditions. So, and prices are starting from $109. Then, of course, we need to move our next most popular product from N to AC. It's a 911. So, basically, it's designed now as a CPE device. and the power is up to 1300 milliwatts. So, but as you can see, there's some pieces looks empty, but let's get to there a little bit later. So, and we offer a solution with the outdoor box, plastic box called net box. Inside is 911 board, AC board. So you can also get these 866 megabits, but you can attach this box to any of your antennas that are already in the network. So no expansions, just a 911 inside. But then we have a full version with everything loaded on the board. It's 922. Also AC, a license for access point. It has SFP, so you can run SFP to your tower and don't have to worry about lightning and such things, because as we know, lightning doesn't travel through optical cables, so you can run optical cable down from your towers. Also, there's mini PCI and a SIM card, so you can put in 3G modem or 4G modem and use it this way. So basically have an internet coming from mobile and then redistribute it with the AC. It also has USBs, so you can use modems on the USB. And it also goes to 1300 milliwatts. But the best thing about this board is that we managed to put it in the solid metal case that also works, so aluminum case, that also work as a big heatsink. So that's why we managed to put transmit power up to 2 watts from this 922 board that's inside this box. And also we managed to make a 3-chain board. So there's actually 4 models available of net metal. So 2 with the 2 chains, 1 with mini PCI, 1 without, and 2 3-chain boards with mini PCI and without mini PCI. So, and all of this is 802.11 AC. So, obvious question is what to put inside this mini PCI Express cage that you have on 911 and 922. You can put this card. So R11AC, it's a dual chain card. Currently it works only on router board products that have mini PCI Express. So for example, net metal. And this card also can get up to these 866 megabits data rate. And what if you want a complete solution? So you really like a net metal and you want to get all MikroTik solution for your point-to-point link. So we introduced a parabolic and dish antenna called MANT. It has 2 mounting types, simple and precise. It has 3-degree beam width and 40 dBm port isolation and 1.4 VSRV. So you can have total MikroTik solution here with net metal, MANT, and maybe a mini PCI card. So this is how it might look if you buy all together and put it all together. Of course, some of you will ask, what about snow, what about water? So, of course, radome cover is available. So, you can also cover your antenna like this. And last thing maybe missing from this MikroTik only solution is how to power this net metals and so on. If you, for example, have fiber to the tower, we introduced fiber to copper converter. So there's lots of these converters in the market, but there's one exception that's good for our product. It's an outdoor solution. So you can put it next to your antenna, next to your net metal, on the tower. So waterproof case, lock screws and works from -40 to +70 Celsius without any problems. So basically nothing is holding you down anymore. You can have MikroTik only point-to-point links from A to Z. So this is a look from the side. So optical in and Ethernet out. Then in the previous month we introduced our new smallest product, Micro AP, or short MAP. So it is also PoE injector. So basically your power goes in via one port and the same power goes out to the next device on the other port. So you can actually have sequence of maps on the one cable. So ideal solutions for schools, hotels, and so on. Just put maps every 10, 20 meters to have a good coverage. So you can power it from almost anything. So it has 802.3 AF, AT, and you can even power it from your USB port. So you don't need any power adapters. Just plug it in like to USB to your laptop and so on, and you have a access point. Or, for example, in the car, you can just plug it into the car charger, and it's ready to go. Then the next product is ceiling access point. So short is CAP. So it will be affordable, and this is a AN product, so no AC for this. And basically all these maps and caps are designed to be easy to use for our new big feature, Caps Manager, our centralized wireless manager for whole network. So these devices were specially designed to be easily configured, attached and configured on the capsmans. And one more product that we are already shipping to the customers, it's upgrade for our 450G. So many of you like this product, so it is exactly the same form factor as 450G, but it has PowerPC dual core 500 MHz CPU. So it's much more powerful than 450G was. And it has 512 RAM. And so basically, it should be a very good upgrade for your 450G installations. And one of the last products that we are shipping is Cloud Router Switch 109. So it's 8-port gigabit Ethernet. And then we have one SFP. And there's USB and wireless access point. So this is all in one solution. It is a switch, it's an access point, it's a router. So you can configure all ports as a switch, or you can choose to configure 6 ports as a switch and use 2 ports for routing. So this is a device that's basically can cover all the needs for the office, small office, or even advanced home. So let's go to the more interesting part, new products. So we continue our Cloud Router Switch 8-port series. So now 210. Cloud Router Switch 210. So let me explain you numbering system. Cloud Router Switch is 100 series. Are without 10 gigs, but with this good CPU. So more router, less switch. Cloud Router switches 200 series have 10 gigabit ports, at least one, but the CPU is a little bit lower, so you should use it more as a switch, less as a router. So 210, it has 8 Ethernets and 2 SFP pluses. So it will be available in October. so somewhere around now. Then we have CRS 112. So again, this is 100 series. So this one has a capable CPU. So actually CPU is exactly the same as 2011. So 8 gig Ethernet ports and 4 SFP ports. This product will be available in November. And the last one, 212, 1 Ethernet, 10 SFPs, and 1 SFP plus. Also coming to November. So basically, with all these combinations, we wanted to allow you to put our cloud router switches anywhere. So have a 10 gig optic in and distribute it to 1 gig fibers or 1 gig Ethernets, have Ethernet switches or something, so everything is covered. You just need, we will make all the necessary devices, so should serve all the available purposes. And the last product is cloud router switch, cloud core router, sorry, 1072. So 72 core cloud core router, so 2 times more than 1036. So first of all, it has dual failover power supplies. You can actually hot swap them. So if one power supply for some reason fails, you can take it out and put a new one in without any interruption of the service. It has a smart card reader to put your certificates on and such things. It has 8 SFP pluses and 1 Ethernet just for management. Also, it has 16 gigs of ECC RAM. So this is our first device that we put a ECC RAM on, and it should be available on this December. So on the last presentations, everyone asked which year, so that's why I added 2014. So it will be available soon. And when registration stops, all of these new products will be available on demonstration table where you register. So maybe not after this presentation, but after 1 or 2 presentations, you can actually come and connect and take a look how cloud router switch looks like from the router OS, how 72 cores looks like in your window, and then you need a bigger monitor to actually see all the cores in the list. So here is a picture of the hot swappable power supplies. And basically that's it for introduction. So thank you for coming to MOM, and there's still more presentations to go, and accidentally next one is also mine. So next one will be about cloud router switches. So thank you. Okay, welcome back. So presentation number 2. So this presentation is already a little bit more technical, guys. So let's talk about Cloud Core routers and RouterOS version 6. So I know that there's many questions, many very actively discussed in the support and also in the MikroTik forum. So I'm the lucky guy who is responsible for all MikroTik CCR lineup in the support. So all the problems, all the issues, all the good news, all the bad news always come in one way or another through me. I even have some guys to help me, but in the end you will get answer either from me or from guys that helps me at MikroTik about RouterOS and CCR. So first of all, let's start with looking at what products will this presentation cover. So currently, this is all the products over here that we offer. So we have Cloud Core routers 9 ports, 16 ports, 36 ports, and soon we will add 72 port support device with 72 cores in this section. So if you have at least one of these boards, then this presentation is for you. So let's start with the tile architecture. So RouterOS support all tile GX CPU processors, so with 9, 16, 36, and 72 identical processor cores. So if I accidentally call them tiles, that in Tilera, tiles and cores are exactly the same. So just so you know, if I'm saying something like tiles, it's just the same CPU cores. And our RouterOS works only on CCR devices. So if you are thinking about getting some device with a Cloud Core router, with a Tilera CPU, but not a Cloud Core router, sorry, but RouterOS will not work on these devices. So RouterOS works only on CCR devices. So tile architecture provides us with hardware accelerated encryption, automatic RPS, and automatic IRQ distribution. So basically, we don't have to worry about any of those things from the software perspective, because hardware is already doing everything for us. So also, CPU have a DDR3 memory and input-output controllers integrated in the CPU. So basically this CPU is a unique solution that provides us with everything in one package. Only thing we needed to do is to make our first ever 64-bit RouterOS version 6. So tile architecture is only one 64-bit RouterOS out there. Every other RouterOS for x86, for MIPS, or for PowerPC are 32-bit. So I know that there will be obvious question, what about x86 64-bit support? Well, it's coming, but it's RouterOS version 7. So you will be able to fully utilize your x86, x64 devices then. So this is one of the most important slides in the whole presentation. So I need you to remember this. So after Ethernet frame is successfully received by interface driver, the frame will be assigned by Linux kernel to a specific core. So one frame to one core, another frame to another core, and so on. Reassigning frames to a different core in the middle of the process, it's very expensive process for CPU and for memory, and it should be avoided. So if you imagine a factory where there's big lines, processing lines, and accidentally you need to switch one product from one line to another line, what happens? You need to stop both lines, put the product in other line, and then only you can restart. So the whole process is very time expensive, so you shouldn't do that. Second thing, processing frames in different cores might take different amount of time. So basically, if you had a packet order 1, 2, 3, 4, and then these packets were assigned to different CPU cores, when processing is finished and the packets come out, the order might be different. So it might be 2, 3, 4, 1 or something like that. And there are some processes and some features that requires that set combination of frames be under control of the same CPU core. So these are three things that we need to manage when we make RotorOS and when you configure your CCR device. So I told you already that CCR devices are very fast. Let's find out how fast they are. So to find it out, we need to eliminate all performance overhead from Linux kernel and from RotorOS. So we introduced a new feature which is called FastPath. So basically, this is the fast way to process packets if you don't use some features. So basically skip Linux kernel processing if it's not necessary. So if you want to use FastPath, first of all, you should allow it in the configuration. Then interface driver must have a support. So all CCR interfaces support FastPath, so you don't need to worry about that. And there's specific configuration conditions. So for example, RotorOS FastPath works on the simple bridge. So if you don't have any bridge rules or use IP firewall enabled, so just simple bridge, FastPath is enabled. So no processing in Linux kernel, just fast way through. Simple routing, the same way. Traffic generator, MPLS, and there will be more handlers in the future. For example, IP version 6 routing will be added. Some simple firewall rules that use header information can be fast-passed. So there is some new FastPath features coming as we develop this feature. Just to show you some numbers. So with the FastPath, 72 core board with the 619 RC6 did almost 70 million packets per second with the small packets. You see the underlined results? That means that port limit was reached. So this device have 8 10 gig ports, so 80 gigs are maximum. So this is a maximum because device didn't have more ports. But the CPU power is still there. And as you can see that Tiller architecture is really scalable. So 9, 16, 36, and 72, the numbers grow almost the same when we look at the packets. So you add more cores, you add more performance. Usually I get this reaction, no, you can't get these numbers yourself in real life. It's some mystical numbers. It's only for advertisement. So, well, you are wrong. Because we have a special tool that allows you to get these numbers that I showed in the previous slides. It's a traffic generator tool. So basically it's the next generation of our bandwidth test tool. And you need just 2 devices. One that runs traffic generator, another one that's under test. to get these numbers. So what can you do with this traffic generator? You can determine transfer speeds and packet loss. You can detect out-of-order packets. You can see latency and jitter values. My favorite thing is you can inject and replay a Wireshark's file in repeat, so PCAP file. So for example, your client asks you to create a firewall that drops this type of traffic, I don't know, torrents or something like that your customers uses. So you go to the customer site, you sniff the traffic, take the file, go back to your lab, put it in the traffic generator, run it, and then make a firewall until you are able to isolate that traffic and drop it. So it's an ideal tool for firewall building on actual customer traffic. And we are working on TCP protocol emulation because it's the only thing missing. And basically, after we add this TCP, we will make a quick mode, so it's as easy to work with as a bandit test. So you can just start and finish. And then we will add the full Winbox support. So I hope that after traffic generator tool is finished, we will be able to delete old bandwidth test tool, which is really legacy. It's a single threaded, limited to single core. So, and all the tests will be done with the traffic generator. And then you can get numbers like this without any problems on your routers. Okay, this was FastPass. What about if I use router-S features? Well, then these numbers are a little bit smaller. So, for example, with the FastPass, there's 30 or almost 40 million on 36 core. But if I add just 25 bridge filter rules, small packets drop significantly, like to the almost 6 gigs, 6 million packets. But as you can see, big packets is still sufficient. You don't see that impact on the big packets. So you would ask, why such a big drop? Well, as soon as you start to use some router-S features, you enable all router-S. And all router-S is lots of different facilities. So you will ask, how many? This is a presentation of the whole router-S. So we have a bridging, we have a MPLS, we have a routing, and if you have some tunnels, it's also possible to encapsulate and decapsulate through tunnels. Of course, this is not just finished of all router-S. You can't put router-S in one page. You need the second page. So basically, these boxes over here are represented like this. And then there's also third page of router-S. So as soon as you start using some of the features, you enable all those three things. So let's start for a very easy example. You have a home router with the bridge interface where Ethernet is bridged with the wireless, so your local network. And then you have a public network which is connected by PPPoE. So very easy setup, usual setup for homes, PPPoE to home, and then you have wireless and Ethernet bridge there. So what happens if the packet is leaving this device, this local network? So it's in diagram, it starts here. Then we ask if the port was bridged. Yes, it's in the bridge, but it's leaving the bridge. So it goes through bridge input. Is it MPLS? No. Is it IP4 or IP6? Yes, it is. So it goes to routing, and it's forwarded. So after routing forward, again check if the output traffic is MPLS, no, bridge, no, but on encapsulate, we know that this traffic need to leave as PPPoE. So that's why it goes here, and now it shows on your local PPPoE interface, and then encapsulation, and then PPPoE packet goes outside. So what about returning packet? So the same principle. Packet arrives, it's a PPPoE packet. So we need to decapsulate it. Then it shows up on your PPPoE interface, goes here, and now it needs to go to routing. So routing forward, no MPLS, but this port is in the bridge. So it needs to go through bridge output and only then to the out interface. So you would say that is it easy enough to see all the processes that packet travels through? So, and you can use this diagram for every possible setup. So I just want you to show you something a little bit more complicated. So this setup is Ethernet over IP bridged with VPLS traffic. That's on the VLAN. So quite complicated setup. I will not go through all the page numbers, but as you can see, number 26 is last. So this is why when you configure RouterOS, some of the things get a little bit slower, because you need to go through all these facilities. So let's go to the features. So queues and multi-core processing. So queues are the place where packets spend most of the lifetime in the router. So basically, in order not to wait in the queue, CPU core will just leave the packet in the queue and go do other things. And then some other random CPU core will come and take some packets out of the queue. So what happens here is basically that queues reassign CPU cores. Remember one of the first slides? I told you that reassigning CPU packet to another CPU core is really bad. But there's nothing you can do in queues. So queues are doing exactly that. They are reassigning CPU cores. So we had to do a big change when we introduced RouterOS version 6. Because in version 5, there was many places where queuing happens. So do you remember such things as global in and global out? So global in was the beginning of the packet life, and global out was at the end of the packet life. So basically, when we first tried CCR device, we had a big problem, because as soon as we had the queues, the numbers were really, really slow. Because queue in global in shuffles packets, and queues in global out shuffles packets. That's why in RouterOS version 6, we eliminated global in and global out, and instead of that, created only one queue at very end of the packet life in the diagram. So basically, we eliminated global in here, and as you can see, global out was before source NAT and before hotspot NAT. So that's eliminated, and in version 6, we just added all the queues at very end of the packet life. So in input, where the packet arrives to the router itself, or on post routing, where the packet is leaving router at all. So this is the reason why some of you maybe had problems moving from version 5 to version 6. because we had to do these changes to make CCR devices to work with at least some of the queues. So also when we did this move, we decided to make a simple queues much better. If in version 5 simple queues was just a quick set for the Q3, so basically you were configured simple queues, but it was, from software view, it was like a Q3 in global in and global out. We recreated simple queues and make them alone, standalone, so they have no relation to Q3 anymore, no relation to HTTP. So first of all, we introduced a matching algorithm. So right now it doesn't matter if your queue is first or last in the Q3, or simple queue list. Everything is hashed, and then packet is matched against this hash value and assigned to the proper simple queue. But there's one thing that you need to remember. For CCR devices to optimally use your simple queues, you need to have at least 32 top-level simple queues. Because one simple queue is limited to one CPU core. So if you have setup, whereas you have one main parent, and then all the queues, it's wrong for CCR devices. Then you are limiting yourself to one CPU core. So you need to have at least 32 top-level queues to optimally use all the capabilities of CCR devices. Please remember that. So what about Q3 on CCR device? Q3, or the HTB queue, from Linux kernel perspective, is and always will be considered as one queue. So one queue is limited to the one CPU core. So this is the current state. So that means that if you have all the traffic captured in a Q3 global, you are limiting yourself to the single core. But if you're dividing traffic to the interface HTTPs, each of these interfaces are limited only to one CPU core. So as soon as we will finish all simple queue optimizations, we will move all those optimizations to Q3 also. So the same rule will apply to Q3s. You will need to have 32 top-level Q3s to fully utilize Cloud Core router devices. So at this point, what I can suggest is to make sure that you use interface HTTPs more than you use HTTP global, because HTTP global is currently limited to the one CPU core. And of course, use simple queues. So version 6.19. This is let's put it this way. There's always most interesting versions of RouterOS come just before the MUM Europe and just before MUM US. Because in those versions are all the interesting changes in. So in 6.19 we introduced a software patch that improved queue performance. So I told you already that before CPU core just left the packet in the queue, and then another random core took that packet out. So now, after this patch, we introduced a feature when if CPU core is leaving packets in the queue, it has to take some random packets out also. So sounds really easy, but if queue is not reaching the limit, so basically queue is empty, so limits is not it. You have 100 megabit limit, but guys are using only like 40 or 50 megs, then this new feature allows CPU core to leave and take the same packet out. So basically, it allows us to make this queuing when limits are not reached basically invisible from performance point of view. So 619 should make all your queues much more faster, so if you're not reaching the limits. Next feature, tunnels. So all the tunnel changes were introduced in version 6.8. So basically what we did, we rewrote all the PPP tunnels, so it's PPP, PPPoE, PPTP and L2TP. And what we did is, first of all, allowed multi-threading on the tunnels, and we rewrote encryption driver. Before, encryption driver was very sensitive to out-of-order packets. So I told you in one of the first slides, if you assign packets to different CPU cores, it will take a different time, and some order changes might be possible. So before, our encryption driver didn't like this at all. So as soon as the packet was in a little bit different order, it dropped that packet and waited until that packet is sent again. So it was a very, very big performance issue till version 6.8. So now our encryption driver supports 256 out-of-order packets. So it's not a problem for our encryption driver. So what's that in numbers? So from 135,000 packets, we got up to 2,100,000 packets for single PPTP tunnel on CCR36. So just with upgrading driver to support out-of-order packets, we got this big improvement. Of course, if you enable all the encryption and all the connection tracking, the difference is a little bit different, like 5-6 times anyway. So PPTP, now L2TP. Numbers here are even better. From 120,000 to almost 3.7 million packets, or 5 times, roughly 5 times when you enable all the features. PPPoE is our best numbers, best improvement. So from 300,000 to 5.5, and if you have a normal sized packets over here, it's something like 7-8 times. So this was done in a version 6.8. So of course, when you introduce such a big patch, you might break something. So maybe some of you had some issues with version 6.8, 6.9 after this upgrade, but I hope all the issues are fixed right now. Maybe some of you noticed that in all these tables, this last number over here sometimes are very small and no changes, no improvements, almost interesting numbers. So what is wrong? The wrong thing is packet fragments. Basically, if you use CCR, you don't want to have any packet fragmentation whatsoever. It's your mortal enemy. As soon as you have fragmentation, your performance goes down. Why? Because currently connection tracking, if you use connection tracking, requires all the fragments to be reassembled in the whole packet. But we can't make it this way so that these fragments are assigned to the same CPU core. So they might be distributed between many cores, and then you need to collect them. And that's very, very expensive processing process. So What we plan to do, and we actually did in version 6.20, we will make automatic MTU calculations for all tunnels. So you will just need to go in the tunnels and make MTU auto, and it will calculate the proper size of MTU for your Ethernet over IP or PoE tunnel that's on this Ethernet over IP. Then we already add path MTU discovery support for all the tunnels. So basically, with path MTU discovery, both ends of the connection can negotiate what is the optimal packet size to send through this link. So if you have some tunnel in between, you can make sure that no fragmentation happens, just by enabling packet MTU discovery. And in some of the next versions, we will update connection tracking so that it can handle fragments. So fragment reassembling will happen only when it's necessary, not always. But currently it happens always, as soon as you enable connection tracking. So, next feature, IP firewall. So, IP firewall is the feature that uses CPU, that uses RAM the most on router-OS devices. So it's most RAM efficient, or affecting the basically RAM speed is directly affected if you use firewall. So you can imagine it's like this, like each CPU core takes the packets and then run through all the sectors in the memory where this firewall rules are located. So after long usage, like some month or something, there was some performance degradation on CCR devices. Maybe some of you noticed that after a month or 2 months, you needed to reboot your CCR device to get the performance back to the level. So we fixed that in 6.19. We introduced Linux kernel patch. So those of you who follows Linux kernel development, you can look up name home cache. So basically we added home cache support to Tilera devices, both with helps of Linux developer and of course Tilera itself. So basically what happens, all memory heavy processes now should work faster and there should be no degradation over time. So that should be fixed. Also we changed something in the firewall. First thing we did, we add a set of interfaces, this matching option that represents all the Ethernets, all the wirelesses, all the VLANs, or all the PPP. So for example, if you use the tunnels and you use change MSS rule in version 5, you had 2 rules for every tunnel. Now you have 2 rules in total. That's it. Also in version 6.19, as you can see, 6.19 version is before the MUM US and all the good changes are in version 6.19. We introduced a firewall patch that optimized option matching order within a rule. So simple options which are easy to process go first and only then go more complex ones. So, and the next thing, maybe some of you noticed, after upgrade to 6.19, some of your rules just got invalid and got red, and there was a comment. This rule is disabled because interface is breached and it can't be matched, or something like that. So what we did, we add an additional check that invalidates all the rules that can't possibly match your packets in your configuration. And we add explanation why. So basically that means that these rules are excluded from firewall and making your configuration to work faster. If some of you wonder what is this matching order within a rule, here is the list. So we start with interfaces, then we go to the IP packets, options, some bridge ports, addresses, address lists, and the most expensive option, layer 7, is last. So for example, if you have a rule that match destination port and layer 7, if destination port fails, layer 7 will never be engaged. So should make your firewall work faster. Layer 7 is the most expensive firewall option. It takes lots of memory, it takes lots of processing power. So basically what you do with layer 7, you match connection or packet stream to the regex stream. Layer 7 is most overused feature in RouterOS. So if you just add simple 50 layer 7 matchers and just action drop to them, it can actually kill your router. So it's wrong to use it like that. You should use it as a trigger. For example, to add it to connection mark or to add address to some address list. And only then you should apply accept to drop when you're matching that address list or that connection mark. So never use layer 7 and action drop accept in the rules like that. So in the same rule. One is a trigger rule which finds the connection, and the other is action rule that actually do something with that connection. And you need to ensure that one connection goes through the layer 7 rule only once, not over and over and over again. It's useless. And it's only take your CPU power from you. Routing in router version 6, RouterOS version 6. So just to make sure, routing itself happens on all CPU cores. So you can use all CPU cores there. But all dynamic router calculations, like protocol calculations, routing table updates, are limited to the single core in router version 6. So for example, if you want to load full BGP feed in router version 6 on any CCR device, it will take around 3 minutes. If you want to load 2 BGP full feeds, it already will take 8 minutes. And currently, 2 BGP feeds requires around 256 megs of RAM. And another minus is searching for some specific routes is very long process. So that's why biggest change coming in RouterOS version 7 is completely new routing. So what we have tested already so far in alpha versions of version 7 that we have. So basically status, we finished BGP. It's already finished and undergoing tests. Currently we are writing OSPF. And when we will be finished with all the protocols, then we probably will give you beta to try out. But results on BGP. One feed loads 2 times faster than in version 6, so 1.5 minutes. But as soon as you add second or load 2 full BGP feeds, it only takes less than 2 minutes. So change from 1 to 2 is really insignificant, only a few seconds. And this scalability continues up to 60 full BGP feeds. also uses much less RAM. So full BGP feed now in version 7 takes 36 megs of RAM. So basically, if you have 12 million routes in route operation version 7, it only takes 500 megabytes of RAM. So we squeezed all these things a lot. Also, main feature is it adds completely isolated virtual routing tables, and it will make much more faster searches. So these changes are coming to route operation version 7. IP security and CCR. So CCR devices, dial processors have a built-in hardware accelerated encryption. And we added support for that in version 6.8. So basically on 36 core device, you can get up to 3.2 gigs of encrypted IPsec traffic. But to get such numbers, you need to remember two things. First thing, you need to avoid fragmentation, because I already told you, fragmentation is your biggest enemy. And second, you need many IPsec peers, because one IPsec peer will add limitation. So some of the things will be limited to single CPU. So you need many peers to get these numbers. So, of course, if you have some performance issues, you need to find out what is wrong. Maybe you are limited to one CPU core or something like that. You can go to System Resources CPU and see load per each CPU core to check. Maybe you are limited, some core is running 100% all the time. And second thing is tool profile that shows you your load distribution over the processes. So as you can see, we improve CCR devices every version. So what happens if you want to try, but you are very afraid, because it maybe will break something? For that, we have a partition feature for you. So you can divide your CCR NAND to partitions. You can copy to other partitions copies of your working version, working configuration, and then you can upgrade to some test version. And if that doesn't work, just one reboot, go in the BIOS, choose the correct partition, and it will boot up to your good version with your good configuration. So this is a very, very useful feature for those of you who want to try new versions, new improvements. So I suggest to all of you that use CCR devices that you must use partitions, maybe not for upgrading, but as a backup, for example. You have a free backup on the device itself. So currently, partitions are very underused features, so please use it. So, and what's next for CCR devices? So first of all, of course, after all these changes is 6.19. Next few versions we will be fixing all the things that might go wrong with these upgrades. So as you can see in version 6.20, we already started to implement MTU calculations, automatic MTU calculations for tunnels. When we will be finished with simple queues, we will update Q3s. And of course, we have several more general performance improvement patches coming in, but I can't discuss with you that now. So basically, CCR devices that you have will become better and better with every version. So we are keep working, and currently I can't say that when we will stop, because there's lots of things that we can still improve. Because hardware allows us to do many things, many different ways, and we are still learning how to do it better with such a number of cores. So that's my update for the CCR devices. Do you have any questions? Okay, you can find me afterwards in the lobby and ask the questions there. So that's it. Thank you.